Hey everybody, in this video we're going to look at a pretty cool technique for making your animations more performant, and specifically we're going to look at animating some CSS properties that typically we would want to avoid animating, CSS properties that don't animate well, and we're going to use this technique to make that perform better and perhaps even as smooth as a normal sort of transform animation. So I don't want to dive too much into the browser rendering process and the general performance concepts in this video, but the basic idea is that when we want to animate something, we change the CSS property, and if we change something like height or width or most CSS properties really that are going to affect the position of something on the screen, it's a very expensive process because we're going to be triggering browser layouts. And what that means basically is that the position of everything on the screen needs to be recalculated and then re-rendered to the screen. And so that takes up a lot of power. So generally when we do our animations, if we focus on just using transforms or opacity to create our animations, we can get something that performs a lot better because they will only trigger the compositor step in the browser rendering process, which is basically the final step in rendering something to the screen. And it's kind of like the process of organizing layers. So we've got everything all painted onto layers already, and the compositor just sort of organizes everything, places it where it needs to be, as opposed to needing to calculate where everything should be. And I also don't want to get too much into the compositor and what that sort of process is like, but you can imagine that everything is already completed, everything's laid out as it needs to be, all the pixels are painted to the screen already. And all the compositor does is kind of rearrange things, move different layers around to where their sort of final position on the screen will be. So the basic idea is that it's not costly for performance. So if we can base our animations on that, we are going to get something that performs pretty well. So just a quick example of this, say this biography card I have here. Let's say if I wanted to move that down, I want to animate it down. I could, for example, animate maybe I want to animate its height to make it a bit bigger. Maybe I animate the margin to push it further down from the fiction card here. But both of those are going to trigger browser layouts. The positions of things on the screen need to be recalculated. But if I use a transform and use, say, translate, for example, which will also move this card down, then it can do that. It can move the card without having to affect anything else on the screen. So there's much less work that the browser needs to do. So that brings me to this particular example, which is not what we are going to be coding in this tutorial. We're going to be doing something a lot simpler. There's quite a lot of code involved in this one, but we'll get to what we'll be building in just a second. I just want to use this as an example. And so for this animation, basically, I want to be able to click on one of these cards here. It's going to expand to fill the screen and shrink back. So in keeping with those rules that I just mentioned about only, where possible at least, triggering that compositor step, relying on transforms rather than things like positioning and height and margins and stuff like that, we need to find a way to basically transform this element to fill the screen. And we can certainly do that quite easily with something like scale. We could just scale this up. So basically use transform to make this 2 or 3 times bigger than it is currently. And that could fill the screen, and that could be the way that we approach this animation, and that would work. But let's say I want to precisely have this card expand to fill the height and width of this screen. That's going to be something that's a bit harder to do with just a transform. So instead, I might want to animate to a specific position. But the problem with doing that is now we're triggering all these browser layouts, all these calculations that need to be done. It's going to make the animation slow, and it's just going to cause general jank in the application. The frames per second is going to be lower, and so it's going to basically be a bad time for everyone. So that's why you don't want to animate those sorts of properties. So if we have a look at this, however, let me just inspect this. I've actually got the animation automatically closing as well, but we'll just try and peek at what is happening when I click this. So if I click biography now, you can see this expanded card position gets applied. And you can see the properties that it has is position fixed, and then top left are both 0. Let me just manually apply these now to show you. So we've got position fixed, top 0, left 0, width 100%, height 100%. and I think we had to remove some margins there as well, but we'll just leave it like that for now. So we've filled up the screen now, but the problem is that we're relying on this position fixed, and we're using top and left, and these are the sorts of properties that we can't animate well with CSS. But as you can see, I clearly am using these properties in some way. So how can I make use of these properties but still have this perform well? And that brings us to the flip concept, which I came across through Paul from the Google Chrome team. I assume he is still working there, I'm not sure, but anyway, I'm not sure if he invented this concept or is just covering it here, but he has a fantastic video that covers the concept in general, as well as a lot of just general performance stuff. So if you're watching this video, you're interested in this video, you'll definitely be interested in Paul's video. So I will link to this blog post that he has here, so you can have a read of that and also watch his presentation on this concept. But the general idea behind what we can do to improve the performance of this animation is flip, so which stands for first, last, invert, play. Now, before we jump into the example of actually building this in our own application, I'll give you a quick explanation of what it is. It might not seem very obvious when I'm just telling you, but first means that we have something we want to animate, for example, this card here. So we want to know what the information, the positional information of this card is at the start of the transition. So before our animation plays, we want to know some details about this card and where it is on the screen. And the next step in the process is last. So the next thing we want to do is put our element in its final state, so we can apply whatever classes we want. And for this case, I want it to expand to fill the whole screen. So what I'm going to do is I'm going to apply some whatever properties I want to get that in its last state. And then I'm also going to then take a reading of that at that point in time to figure out all the positional sort of stuff. And this is where the trick of it comes in. So the invert step, what we do is we do some calculations based on that first position and that last position, and we use that information to sort of invert the animation. So we're taking our final state, which is the expanded card here, and we're going to apply some transforms, which again are CSS properties that we can animate with a very high performance. We're going to use that transform to get it back into this initial state. So we're starting from the end and transforming back to the start. And then the final letter in our flip acronym is P, which stands for play. And so basically we just remove that transform and that will play our animation. So I know that probably sounded very confusing, so I want to briefly, again, cover what's happening there. So we start our animation in the final state. To get to that state, we just apply CSS properties just straight up, no animation, just plonk it all on there, get it in this final state. And then we use transforms to put it back into its initial state. And then to animate it, we again just remove those transforms, we animate it now, and it's going to look like it's just animating to that final state. Whereas really everything's kind of reversed. So I hope this is going to be a lot clearer when we go through a simple example, because to explain it with words, at least for me, is quite difficult. Maybe Paul does a better job than I do. So definitely, again, check out his video and then maybe come back to this one and we'll go through a little example of creating a simple version of this in an Ionic application. Okay, so I've got an Ionic application on the screen now. This is an Ionic and stencil application. As with most of my tutorials, it often doesn't matter. So if you're using Angular or React or Vue or whatever, you should be able to use the same concept still in those frameworks. It just might look a little bit different in places, but this concept can be applied absolutely anywhere, even outside of Ionic completely. This has nothing to do with Ionic specifically, but we will be using the Ionic Animations API to make these animations easier to create. So let's start by just getting something set up on the screen. We want to animate a card, so let's just remove everything from our home page. Get rid of the header. And this isn't going to look as pretty as the other example. But we're just gonna, basically just have some placeholder content to work with. Let's add a header, I guess. Say hello. And then that should be Ion card content. This is a cool animation. So let's see what we have there. So that's good enough. We have just a white card. I'll probably color this just so that we can see the effect a bit better. Let's go with, let's pick a color from here just to get something nice. Totally unnecessary, but we'll go with the same thing. We'll get that red I used in the other one as well. All right, so let's just add that to the CSS for this now. So we'll just say Ion card, and we'll give that an Ion item background of the color we just got. And we'll change that text color as well. I think I can change it with the Ion text color. We'll make that white. No, that's not it. Let me just check in the element here. We should be able to just overwrite color instead. That'll make things easier. Cool, so we have this card now. Hello, this is a cool animation, and it is just a squarey card on the screen, which is great. So what we want to do is animate this to fill up the whole screen. That's our goal for this tutorial. And we're going to follow the flip principle to do that. So let's get into the code here. So what I'm going to do is make this a button, and we are going to call a method when it is clicked. And that is going to, we'll just call it, I will call it expand card. And so we'll call this .expand card. And let's just check that's all wired up correctly. Just say expanding. Come back into the app. We will just give that a little refresh, click on our card, and you can see we get expanding logged out, which is exactly what we want. So now let's focus on doing this animation. So the flip concept, F-L-I-P. So we have the F, which is first, last, invert. Every single time I try to write invert, I write invest. I don't know why, but that happens. First, last, invert, play. So what we want to do in the first portion of this animation here is we want to get the information about our card. So we want positional information, which we can do with get bounding client rect. And what this will tell us basically is how wide, how high the card is, and also how far from the top of the screen it is and the left of the screen. So basically it's going to give us all the positional information we would want to know. So what we need is a reference to the card. So I'm going to do this in a stencil-y way to get a reference to our card element here. Whatever you are using, whether that's Angular or whatever else, just get a reference to the Ion card DOM element because we'll need to make use of that. So for the case of stencil, what I'm going to do is just get a reference to the host element, which in this case is just our home page. And then I'm going to use that to run a query selector to grab our Ion card. And once again, I should probably assign that to something as well. So I'm going to make this a class member variable. Say public card. Should be a HTML Ion card element. So say this.card equals that. Console.log this.card just to make sure that we have a reference. I should probably get rid of that for the second to stop that from messing things up. And cool, so we have our reference to our Ion card element there. So now what we can do is say const first equals this.card.get bounding client rect. And again, just to show you what we're working with here, console.log first. Now if I click on this, I get DOM rect. And you can see we have an X, Y, width, height, top, right, bottom, and left. So that's all the information we need, but we don't need to use it just yet. So next, let's do the last step of this process, which is actually the second step, which is kind of funny. So basically at this point, we want to apply the CSS that will be our element in its final position. So what I want to do is say this.card.classList.add, and we'll just call this expanded card. Now, again, this is something that depending on what framework you're using, there might be a different way you go about adding a class to a particular element. So just do that, but it's the same sort of concept. So now, of course, I'm going to need to define the styles for this. So let's create another CSS class in here called expanded card. And we want to apply some styles that are going to make this fill up the screen. So let's just inspect element there, go to the Ion card, and let's see what we can do. So you saw in the other example I showed you, we're using position fixed. We had a left of 0, a top of 0, width of 100%, height of 100%, and then we also need to get rid of those margins. So we'll say margin 0, and there we go. Now we have the card filling up the whole screen. So this is the final state of our animation. So I want to take that, apply that to our expanded card class here. And now when we click this button, it's going to apply this class to it. So let's just actually check that that is what happens. So we will refresh this. And now if I click on that card, you see it just pops straight into that expanded state. So this doesn't, you can see there is some animation because when you click on the card in Ionic, if it has that button attribute, it does a little pulse animation, but it doesn't animate to the full width of the screen. It just pops straight there, which, you know, really doesn't even look that bad, to be honest, but we want to have a smooth animation so it sort of grows into that position. So we now know we're in the last state. So what we want to do is get a reading over that. So we'll say const last equals this.card.get bounding client rect. So now we have information of where the position of the card should be before the animation starts and after the animation finishes. So the next thing we are going to do is do the invert step, which is kind of the tricky part. But basically we want to go from this state, which we're going to actually start in, the final state, and we want to transform it back to this initial state. So we're going to calculate some values to do this. So I'm going to create another const here called invest again. That should be invert. And I'm just going to create an object here. You can create this a bit differently if you want. But we're going to get some X and Y values to know where we need to translate this to on the screen. So the value for this will be first.left take last.left. And then the Y translation will be first.top take last.top. Then we will scale in the X direction. And that will be first.width take last.width. And we'll scale in the Y direction, which will be first.height take last.height. So basically this gives us the values we need to transform to get from this final state back into this initial state. So now we can create our actual animation. And so what we want to do is animate from our transformed initial state out to our final state. So the initial state is going to be this last state, but transformed back into the initial state. And then we'll animate to the initial state. Now, I realize that might sound weird. So I'm going to say it one more time in here. So we'll have our expanded state. So when we click on this, we go to this expanded state. So the animation hasn't even started yet. And so then what's happening is our animation before it begins is going to apply a transform to this final state to shrink it back into that little card. And that's when the animation starts playing. Then the transforms are removed, and as they're removed, they will transition to the full expanded card. So let's pull in the Ionic Animations API now. So we'll import create animation and animation from Ionic Core. And again, if you're using a different framework, Angular, for example, I think you would import the Ionic Animations API a bit differently from Ionic Angular. It's been a little bit since I used that, so I can't remember exactly what, but I don't think you'd be importing this from Ionic Core in that case. And then what we want to do is create the animation, so const expand animation, and I'm not going to cover how the Ionic Animations API works either in this video, so I'll try to link to some additional resources for that. So equals create animation, I want to add element, this.card, we'll give it a duration of 300 milliseconds, give it an easing of ease in out. We're going to need to apply some before styles here. So basically we want to apply this style before the animation begins, and we just want to give it a transform origin of 0, 0. And then we get to the actual animation part of this, which is from to. So we want to animate from something to something else. So we want to animate transform. We want to animate it from our inverted position. So that means we're going to translate it from the scale x value here. So we'll say invert.scale x and invert.scale y. And as well as translating, we also want to scale it using our x and y values here. So we'll scale from invert.x and invert.y. And then all we want to do is animate that from these values to whatever their initial values were, which is going to be translate 0, 0, and scale 1, 1. So I've already kind of harped on about this quite a lot already, but I'll do it one more time. So up here, we are setting the CSS class expanded card on our element. So it's already in that fully expanded state. Now we do some calculations on that, and then when we get to the actual animation, what this is going to do is use these transform values, these invert values we calculated, to set the beginning of the animation to be to have this expanded card shrunk back to its initial size. And then we remove that by animating to its normal size. And remember now that its normal size is the expanded size. So it's all very backwards, so it kind of takes some getting your head around, but once you get there, it makes sense, I promise. So if it's not making sense, maybe just play around with it a bit, keep thinking about it until you can sort of get it in your head. It took me a while at least. And so now basically we just want to play that expand animation. So we'll say expand animation.play. Nope, that shouldn't be a function. It should just be expand animation.play. So we'll save that and we'll see if everything's working. It's a good chance it won't be, but we will hope. So let's try clicking this. And what have I broken? I do this almost every time I try to scale something. I forgot the pixel values for the translate. So, oh, and I just realized also I got the values backwards for some reason. I don't know why I did that, but I used the scale values for the translate and the translate values for the scale. So I just swapped those back around. Sorry if that was confusing. So that should be invert.xpx, invert.ypx, and this one should be invert.scalex, invert.scaley. So let's give that another try. And I actually have another mistake here too. This is, it's not supposed to be we're not supposed to take the width from the first and the last. This is divided to give you a sort of ratio to scale with there. So hopefully that's the last of the mistakes there. Let's give this another shot. So we'll click on the card and we now have it animating as we wanted. And so you can see that kind of just smoothly animates to fill the screen. We can see an animation inspector here to see sort of what it does. So, and this gives you a better sense of what is happening too. So at the beginning of the animation, you can see this transform has been used to shrink this card back down to its initial size, and then it's expanded out again. So what you also might want to take care of here is you can see, like, as we transform this, the text content inside of the card is getting scaled. And so you do get, it looks a little bit weird just having that sit in there and having that sort of shrink and expand. As far as performance goes, it's not really going to be a problem, but it just looks a little bit weird. So what I ended up doing for the original example I showed you, in that case I just animated the title as well. So I animated the title away and then had it come back afterwards. There's different approaches you could take to doing that, but just keep that in mind that the text is probably going to look a bit janky if you leave it in there just static. But if we just delete that for now and have a look at what our animation looks like with just the card, you can see it just sort of smoothly expands to fill the screen. So one final recap of what is happening. The first thing we do is we get a reading of the position of our element as it is in its initial state. Then we apply a CSS class that will get it to its final state, and we take a reading of that as well. The element will stay in its final state with that CSS class applied, but then we calculate this invert, or these invert values, to transform the final state, the fully expanded state. We transform that back into the initial state. So now it's back in the initial state, but it's been sort of squashed there with transforms rather than with CSS, normal CSS properties. Now once we have our card squashed into its initial state, we then expand it back out to its full state with this animation, which you can see here. This is where it does the squashing. It animates from the squashed state with transforms to the original state, which is the expanded state. So I hope this video was clear enough. It is a difficult concept, I think, to wrap your head around, but the implications are pretty huge. You can do some pretty cool stuff with this, some things that typically you might not be able to do. And the whole concept relies on the fact that you have about 100 milliseconds to do something before the user will notice that nothing has happened. So if I click on this button and nothing happens for 100 milliseconds, I won't even notice. But if we wait longer than that, that's when a user might notice that, well, hey, I clicked this and nothing happened. Oh, there it is. And it creates that kind of janky experience. So basically what we're doing is in that initial 100 milliseconds, we're doing all of the sort of grunt work. We're doing those calculations we need for our animation. And then after that, we can just play the animation smoothly using transforms, which are going to be performant, rather than doing heavy, complex work during the animation. So it's a pretty cool concept, I think. And once again, Paul does a fantastic job of explaining it all and all the sort of general concept behind it. So again, highly recommend you watch that video. I hope you enjoyed this one. If you did, do feel free to leave a like and subscribe, and I will see you in the next video.